The history of the special theory of relativity, STR, is a captivating narrative that begins with the revolutionary ideas of Albert Einstein in the early 20th century. 1. Background and puzzles in physics. At the turn of the 20th century, classical physics, as formulated by Newton and Maxwell, was highly successful, but faced challenges in explaining certain phenomena. The constancy of the speed of light in Maxwell's equations and the inability to detect Earth's motion through the ether raised questions about the nature of space and time. 2. Einstein's Annus Mirabilis, 1905. In 1905, Einstein, a relatively unknown patent office clerk, published 4 groundbreaking papers that reshaped physics. This year became known as Einstein's Annus Mirabilis, Miracle Year. One of these papers introduced the special theory of relativity, STR. 3. Postulates of STR. Einstein's STR was built on 2 postulates: constancy of the speed of light. The speed of light, c, is the same for all observers, regardless of their motion. Principle of relativity. The laws of physics are the same for all observers in uniform motion. 4. Time dilation and length contraction. STR introduced revolutionary concepts. Time dilation. Time slows down for an observer in motion relative to a stationary observer. This was supported by the famous twin paradox scenario. Length contraction. Objects in motion appear contracted along the direction of motion. 5. EMMC squared and mass-energy equivalence. Einstein's equation, EMMC squared, emerged from his exploration of the relationship between mass and energy. This equation signifies that mass and energy are interchangeable and provided a profound insight into the connection between matter and energy. 6. Experimental verification. Initially, the implications of STR seemed counterintuitive, but experimental evidence gradually supported Einstein's theory. Experiments such as the Michelson-Morley experiment and subsequent ones confirmed the constancy of the speed of light. 7. Recognition and impact. Einstein's work in 1905 laid the foundation for a new era in physics. Although initially met with skepticism, the scientific community gradually recognized the validity of STR. The theory profoundly influenced subsequent developments in physics, paving the way for further exploration of the nature of space, time, and motion. 8. Legacy and continued relevance. Special relativity became a cornerstone of modern physics, influencing fields beyond theoretical physics. The history of the general theory of relativity, GTR, is a compelling tale of scientific innovation and a transformative shift in our understanding of gravity. Let's explore the key milestones in the development of GTR. 1. Prelude to general relativity. In the years following the formulation of the special theory of relativity, STR, in 1905, Einstein continued his quest to extend these principles to include gravity. The equivalence principle, which states that gravitational forces are indistinguishable from acceleration, became a crucial concept in Einstein's evolving thoughts. 2. Struggle for a unified theory. Einstein sought a unified theory that would encompass both electromagnetism and gravity, striving for a comprehensive understanding of the fundamental forces in the universe. Early attempts at a unified theory faced challenges, leading Einstein to refine and reformulate his ideas over the years. 3. Road to general relativity. By 1911, Einstein was exploring the geometry of curved spaces, influenced by mathematicians like Riemann and Minkowski. His realization that gravity might be better described as the curvature of space-time set the stage for the development of GTR. 4. Publication of General Relativity, 1915. In November 1915, Einstein presented the complete form of the general theory of relativity through a series of 4 papers. GTR replaced the force-based description of gravity with a geometric model where massive objects curve the fabric of space-time. 5. Key elements of general relativity. Equations of general relativity. Einstein's field equations, a set of 10 interrelated differential equations, describe how matter and energy influence the curvature of space-time. Curvature of space-time. Massive objects, such as planets and stars, create a curvature in space-time, and this curvature influences the motion of other objects. 6. Early tests and confirmations. GTR made several predictions, including the bending of light by gravity, gravitational lensing, and the shift in the orbit of Mercury. Arthur Eddington's 1919 expedition during a solar eclipse provided experimental confirmation of the gravitational bending of light. 7. Expanding influence. General relativity quickly gained recognition as a groundbreaking theory, with scientists and mathematicians exploring its implications. It became a cornerstone for further advancements in cosmology, contributing to our understanding of the universe on both large and small scales.